Welcome to The Explainer. Today we're looking at something that feels completely permanent, but is actually slipping away right before our very eyes. We're going to explore how Jupiter's famous, swirling Great Red Spot, a storm that has literally raged for centuries, is dying. But honestly, more than that, we're going to look at how this disappearing storm is actually a window into a pretty terrifying, existential cosmic truth about the universe itself.
Okay, let's dive into this. For over 350 years, humanity has looked up and seen this iconic, giant red eye just staring back at us from the largest planet in our solar system. It feels totally eternal, right? You've seen it in textbooks. You've definitely seen those stunning images from NASA's Juno spacecraft. But here's the crazy thing. In as little as 20 years, it could be completely gone. And the scariest part?
Section
It
1.
is definitely
the
not
dying
the only
behemoth.
thing in our universe
So
that is
before we can
disappearing.
even really wrap our heads around the death of this incredible storm, we kind of need to grasp the sheer scale of the monster that hosted. Get this. You could fit 1,300 of our tiny Earths inside this gas giant. 1,300. Its internal volume is over 1 quadrillion cubic kilometers. It is a world of just absolute mind-boggling, terrifying scale.
Jupiter is literally a planet of ridiculous extremes. It boasts 2.5 times the mass of all the other planets in our solar system combined. It's spinning so incredibly fast that its equator is whipping around at 43,000 kilometers per hour, making a day there just 10 Earth hours long. And deep beneath its atmosphere, this insane pressure compresses gases into a massive swirling ocean of liquid metallic hydrogen. It actually conducts electricity down there. And perhaps most amazing of all, if Jupiter had just grabbed 13 times more mass during its formation, it would have ignited into a star. It's the absolute ultimate stage for the solar system's greatest storm.
And this brilliantly illustrates just how drastic things have changed. Back at its peak observation in the 1800s, the Great Red Spot was an absolute leviathan. It stretched over 48,000 kilometers wide. Think about that. You could drop 3 Earths side by side right across it. But today, it's shrunk down to just 16,350 kilometers, which is about 1.3 times the width of Earth. And not only is it shrinking, but it's transforming from this highly elongated oval into a much more circular shape, which means it isn't just losing its size, it's actively losing its structural integrity.
Section 2. Anatomy of an anti-cyclone.
So what exactly is this beast, and how on Earth, well, actually how on Jupiter, has it survived this long? Here on Earth, we're used to cyclones, which form around rising low-pressure air. But the Great Red Spot, it's the exact opposite. It is a gigantic anti-cyclone. We're talking a massive high-pressure system rotating counterclockwise, generating winds howling at speeds close to 700 kilometers per hour. Just for some context here, the fastest cyclonic wind ever recorded on Earth was just over 400 kilometers per hour. The extreme turbulence in Jupiter's storm actually creates these powerful acoustic waves that heat the gases above it to temperatures hotter than literally anywhere else on the planet.
Now, the secret to a centuries-old storm really comes down to the Coriolis Effect. Basically, slow-moving air from Jupiter's poles meets up with incredibly fast-moving air from the equator. And as they interact, they start to curve, creating this massive circular motion. Because Jupiter has these very distinct atmospheric bands flowing in opposite directions, the Great Red Spot basically gets trapped right in the middle. It essentially sits on a gigantic planetary-scale conveyor belt of pervasive countercurrents. And that's exactly what has kept it spinning relentlessly for over 350 years.
But right about now, you might be wondering, so what? Seriously, why does it matter? Why should any of us care if a swirling cloud of gas hundreds of millions of miles away just disappears? Well, let's bring this directly back to our own survival here on Earth.
Section 3. The earthly stakes.
So the crucial point is that studying this dying behemoth actually gives us the critical theoretical tools we need to understand our own atmosphere and oceans. Specifically, it teaches us about a phenomenon called atmospheric blocking. By studying the Great Red Spot, which, if you think about it, is basically the ultimate extreme version of a blocked high-pressure system sustaining itself against surrounding turbulence, scientists have been able to refine their fluid dynamics models right here at home. Atmospheric blocking is what happens when our own high-pressure systems get stuck over a region, and that lack of atmospheric movement is exactly what causes devastating heat waves or absolutely deadly cold spells.
The stakes of this knowledge are just immense. Because of the models refined by studying Jupiter's storms, meteorologists and food security modelers can actually predict atmospheric blocking weeks in advance. Without these early warnings, which give farmers time to adjust their harvests, just one unlucky set of blocking events could wipe out 3% of global food production in a single year. 3%? We're talking millions of tons of food. So this isn't just some hypothetical space science, it's a real-world application that literally saves lives.
Section 4.
The cosmic erasure.
But this crucial data window is rapidly closing. And as the Great Red Spot fades, it kind of forces us to confront a much larger, wilder realization. The universe is actively erasing its own history. We've actually lost incredible scientific opportunities before. Back in 1665, the astronomer Cassini documented a permanent spot on Jupiter. But after his initial tracking, that spot wasn't definitively recorded again until 1831. That is a 166-year gap. Modern scientists believe Cassini's spot likely just collapsed and dissipated entirely in the dark, with no one watching. The exact same thing happened in 1989 when we observed a great dark spot on Neptune. Just 5 years later, by the very next observation, it had vanished completely. Entire planetary histories, these massive datasets, can simply disappear silently without a single trace.
As the source material points out, the disappearance of the Great Red Spot is really just a mini version of what's happening to the entire universe itself. It's a cosmic tragedy. We naturally tend to think of the universe as permanent, mostly because our human lifespans are so incredibly short. But on a deep cosmic timescale, the universe as we know it is winding down, actively hiding the clues of its own existence.
The mechanics of this cosmic erasure are totally unstoppable. You see, the universe isn't static, it's expanding, it's spreading out, and that expansion is actually accelerating. Right now, distant galaxies are moving away from us faster than the speed of light. And because of this, these vast, dark swaths of absolutely empty space are forming between galaxy clusters. The universe is permanently deleting the evidence of its own origins. It's just sweeping the data right away, over the cosmic horizon.
Section 5. Our privileged window.
This all leads us to a pretty profound philosophical conclusion. Humanity happens to exist at an incredibly lucky, incredibly fleeting moment in cosmic time. Think about the Big Bang for a second. Right now, we can still detect its echo through the cosmic microwave background radiation. But as the universe expands, this radiation is stretching out, or redshifting. Its remaining energy is continuously being diluted. Eventually, this faint glow is going to become completely undetectable. The very echo of the universe's birth will just fade into silence, leaving future beings with absolutely no evidence that the Big Bang ever even happened.
Now, what's really interesting about this slide is the terrifying contrast in perspective. Humanity happened to evolve in this super narrow, privileged window. The Earth is old enough to have formed complex life, sure, but the universe is still young enough that we can map 2 trillion galaxies and actually pinpoint our origins. But consider a civilization that evolves, say, 2 trillion years from now. They are going to look through their telescopes and see almost nothing. Just a few merged local galaxies surrounded by an immense, suffocating nothingness. They literally won't even have a scientific reason to suspect there's anything beyond their immediate neighborhood.
In 2 trillion years, future civilizations are going to have a universe-sized hole in their science. They will inherit a quieter, darker, and vastly less legible universe. We can't stop the Great Red Spot from fading, and we certainly can't stop the universe from erasing its own history. But we have a privilege that they won't. So please don't take this fleeting window for granted. Go outside tonight, grab a telescope and point it at Jupiter. Watch a 350-year-old storm churn in the darkness while it's still there. Because one day, very soon, the universe is going to turn the lights out on it forever. Which kind of makes you wonder, what other cosmic secrets have already faded into the dark before we even got the chance to look?